Hello, good evening and good morning. Ito na naman ang inyong Pinoy Physics teacher. At nagbibigay ako ng mga solution sa mga binigay kong mga problem sa inyo. This time, mga third quarter solution problems naman. So just like what I've showed you last time, I was giving you just examples. But this one, these are actual solutions sa mga problems na given sa module on third quarter. Okay, we start with week 1 exercises. And in the week 1 exercises, we have two problems. Number 1 is, this is the problem. Ito yung problem, no? Find the magnitude of the electric force between two protons separated by 1 femtometer. Approximately the distance between two protons in the nucleus of a helium atom. The answer may not appear large, but if not for the strong nuclear force, the two protons would fly apart at an initial acceleration of nearly 7 times 10 to the 28 meter per second squared. So, what is the force between two protons separated by 1 femtometer in the nucleus of a helium atom? So, we have, question is, we have two protons. Ang charge ng proton, usually Q sub P, is equal to positive 1.602 times 10 to the negative 19 Coulomb. Yan ang charge. They have a separation of R is equal to 1 femtometer. 1 femtometer, which is equivalent to 1.0 times 10 to the negative 15 meters. So, yun ang mga given values. Meron pa siyang values that are not given but definitely part of the solution. Tinatawag nating electrical constant, which is just we just write it at 9.0 times 10 to the 9 Newton meter squared per Coulomb squared. So, ang question, what is the force between those two protons in the nucleus? Okay, so nucleus of a helium atom. So maximum na yung dalawang proton na yan. So how do you get that answer then? Let's see. We all know that according to Coulomb's law, F is equal to K sub E Q1 Q2 over R squared. So we already know the value of R. We already know the value of Q. Since dalawang charges yan, we just write as that K sub E Q sub P squared all over R squared. So we write that once more, 9.0 times 10 to the 9 Newton meter squared per Coulomb squared times Q sub P. Ito yung Q sub P. So we write that at 1.6 times 10 to the negative 19 Coulomb divided by yung R, which is 1.0 times 10 to the negative 15 meters. Parehan lang natin silang i-square, pero pareho lang naman din yan. So, Q over R squared or Q squared over R squared gives you the same answer. So, we just bring down this one, 9.0 times 10 to the 9. The units, no, I don't. Then you square both sides of this. You either divide first then square, or square first then divide. So I would suggest I would divide first then square it. So I divide 1.6 by 1 is still 1.6 times 10 to the negative 19 plus 15 would be negative 4 Coulomb per meter. Saka mo siya i-squared. So yun ang F. F is therefore equal to, again, bring it down, 9.0 times 10 to the 9 Newton meter squared per Coulomb squared times Yung square nito, what's square of 16? 2.56 times 10 to the negative 8 coulomb squared per meter squared. So, dito pala makikita nyo na ang solution. Okay, so you can cancel that out. Squared naman yan. Cancel this out. So you're left with 9 times 2.56. Now, what is the value of 9 times 2.56? So 23. In the product ng 9 tsaka 0.04 times 10 to the, okay, this is 9 at saka minus 8, that gives you 1 Newton, or 230, approximately 230 newtons, or scientifically can be written as 2.30 times 10 to the 2 Newton. So either of the two will do as your solution. Okay. Madali lang. This time we'll be solving yung problem number 2. The problem number 2 states naman na 3 charges lie along the x-axis. Now, Q1 is 10.0 microcoulomb at x is equal to 1.0 meters. And the negative charge Q2 is at negative 2.0 microcoulomb, which is at the origin. Where must be a positive charge Q3b placed such a way that the resultant force between them is 0. So, ganito yung problem. So, ito daw yung coordinate plane mo, no? Then, ang sabi doon, ang Q1 mo is at 1 meter. So, therefore, meron tayong 0 is now 0 is now 1 meter. Ito yung x mo, no? Okay. Ang nakalagay sa 1 meter is 10 microcoulomb dito. Ang Q1 mo is 10 microcoulomb. And sa Q2, Q2 negative 2.0 microcoulomb. So ang R mo dito is, or x, 1 meter. Ang question is, saan mo ilalagay yung Q? In such a way, you have Q3. Okay, Q3. Where are you going to place that? In such a way na yung net force na combine ng dalawa sa Q3 is 0. So let's first look now. Kung ang Q3 ilalagay mo dito sa negative side, which is before x, my experience na dito is sa Q2, Q3 and Q2 will be something like attractive. Kasi ang Q3 is, assign lang natin siya na positive. So ang Q3, pa ganon. On the other hand naman, parehas lang positive nung Q1. So, Q1, Q3 positive, Q1 positive. So, pa ganon. So, ang effect ng Q1, yung blue. Ang effect ng Q2, yung red. So, nagka-cancel out. On the other hand, kung ilalagay mo naman ng Q3 dito, baligtad ang effect. Yung Q3, pa ganon. Tapos ang Q2, pa ganon. Since mas mahina itong Q2 sa Q10, I don't think this part pwede siya. Pero dito, since mas malayo ito, therefore mas malakas ang effect nito since closer siya, no? Mas mahina yon. Since this is larger, it's better to place the charge here. So, we will not assume na nandito siya sa position na to. We don't know that position. So, we will solve for that one. So, let's call that R1. At R1, or in that case R, what would be the value? So, ang gawin natin, i-equate lang natin yung dalawang forces. Okay, so, between Q3 and Q2, ano ang equation? F32 is equal to K sub E, Q3, which we don't know, times Q2, which is Hindi na natin specify negative 2 kasi nga specify na natin direction ahead. So therefore, the negative 2, we just assign yung absolute value niya, 2 microcoulomb. Divided by yung distance na to. We call that R1. On the other hand, ano yung effect naman ng equal daw siya sa F13 o F31, no? In that case then, this F13 is equal to K sub E pa din, Q3 pa din, pero Q times Q1. Since again, na-assign na yung direction, we will not write anymore we just write the value. All over, squared pala yan, no? This one naman, hindi siya, no? So, this distance has to be either X plus R, no? Yung distance niya would be X plus R. The X, which is 1 meter naman anyway. So, let's say, write 1 plus R1 quantity squared. So, equating the two, we come up with K sub E Q3 2.0 microcoulomb all over R1 squared equals K sub E Q3 10 microcoulomb over 1 plus R1 quantity squared. Again, dito pala makikita nyo na cancelled out to. O, yan, cancelled out yan. Since nandito parehas lang may micro, even yung prefix niya maka-cancel out din. In fact, yung unit nga is cancelled out din. So, this one is also cancelled out. So, what are we left with na? Okay, so let's continue. Our formula then starts with 2.0 over R sub 1 squared equals 10.0 over 1 plus R sub 1 quantity squared. This one can now be reduced or expressed as 2 times 1 plus R sub 1 quantity squared equals 10 times R sub 1 squared. And this one can be easily simplified as 1 plus R sub 1 quantity squared equals 5 R sub 1 squared. And then eventually, papunta siya sa expanding this expression. We have 1 plus 2R1 plus R sub 1 squared equals 5R sub 1 squared. Rearranging, we now have our expression become 0. Transferring all of this to the other side, we have 5R sub 1 squared minus R1 squared. R sub 1 squared gives you 4R sub 1 squared minus 2R sub 1 minus 1. Now, notice that we have this expression and this one can only be solved using quadratic equation. Our quadratic equation can be written as R1 equals negative B plus or minus square root of B squared minus 4AC all over 2A. So notice that we have now this 4, that's our A, this negative 2, that's our B, and this negative 1, that's our C. So substituting the values, then we have R sub 1 equals negative of negative 2 plus or minus the square root of B squared, so negative 2 quantity squared minus 4 times A, which is also 4, times C, which is negative 1, all over 2 times A, which is 4. Okay, so we come up with 2 plus or minus the square root of 4 plus 16 all over 2 times 4. Bear in mind that this one is square root of 20. It's also equal to 2 times the square root of 5. Square root of 4 times 5 kasi yan. So, okay, again, continuing, we have r sub 1 is now equal to 2 plus 2 square root of 5 divided by 2 times 4. Now cancel out. Factor this one out and cancel that together with 2. So you're left with 1 plus square root of 5 over 4. And one of the other answers is 1 minus the square root of 5 over 4. This one eventually leads to, we now know that our equation, square root of 5 is about 2.236. So this becomes, this is 9, correction, and this is 309 also. It's not 6, this is 9. Okay, so however, our final answer is not the positive of 0.809 because in our previous analysis, the location of R1 is on the negative side of the x-axis. So therefore, this one, 0.809, refers to the absolute value from 0 to that position. To the position, in that case, that position then it lands on R1 equal to negative 0.809, referring to its position on negative x-axis. So this is the correct answer. Suppose you were able to understand that. Okay, that's the answer for exercise number 2 for week 1.